our first podcast is going to be about solving exponential equations. So remember, we're getting into logarithms pretty soon, and a logarithm is just another way of saying an exponent. So when we first do solving exponential equations, we do with like bases, and it's very simple. For example, if you had 3 as a base and it was raised to the 10th power, and it is equal to 3 to the 5 times x, and it says solve for x. So when you have like bases, if bases are equal, then you just set the exponents equal to each other and solve for x. It's very easy. So since our bases are equal, we would say 10 equals 5x, and to get x by itself, you would divide both sides by 5, so 2 would equal x. So here's the problem I would like for you to do. Solve for x. 2 to the 8th is equal to 2 to the x plus 1. Solve for x. Solve for x. So you hit pause and work it, and I'll go throw in some laundry and you can come back. Alright, so you have solved the problem now, and you push play, and so you see that you have like bases, and therefore you set your exponents equal to each other, and then get x by itself by doing opposite operations. So I would subtract 1 from each side, and so 7 equals x. Now you don't have to take my word for it. You can just substitute x back in to see if it works. So 7 plus 1 is 8, and then 2 to the 8th is equal to 2 to the 8th. You know that. Very simple. So let's talk about compound interest. And so A stands for the amount at a certain time period. If you invest some principal, which is the money you've got to invest, then you multiply that principal times 1 plus the interest rate divided by k, which is the number of times compounded, and it's raised to the number of times compounded times t. So A stands for amount, P is the principal, which is the money you started with. The amount is the amount at the end of the interest rate in the time period. And R is the rate, where you always change the rate. If it says 7%, you change it to a decimal by moving the decimal 2 places to the left, so that would be 0.07. That's just an example. K is the number of times compounded. All right. So you need to review that. If it says annually, that's 1 time a year, K equals 1. Biannually is twice a year, so K equals 2. Quarterly, K equals 4. Every 3 months. 3 times 4 is 12. There's 12 months in a year. So monthly would be K equals 12. There's 12 months in a year. Weekly, there's 52 weeks in a year. And daily, we would say 365. And you could keep on going. You could go by hours, but they don't usually do that. That's when you get into continuous compound interest. So let's look at a problem that's like number 2 on the take-home test. And I will now mention my pet's name. And the first pet that I'm going to mention is Lucy. Lucy. So we have this problem. And like I said, this is like number 2 on the take-home test. If $2,000 is deposited in an account paying 6% compounded quarterly, I won't write all of that down, but 6% compounded quarterly, what amount will be in the account after 8 years? Oh, I forgot to mention something. Let me go back. I didn't talk about T. T is time, and time is always referred to in years. So if somebody says in 6 months, you don't say T equals 6. 6 months is half of a year. So if it says 6 months, you would say 0.5. You have to change it and put it in terms of years, okay? So back to the problem. If they want to know how much would you have after 8 years. After 8 years. So I changed some of the numbers in this, but you would actually use the formula. The amount is equal to the principal times 1 plus the rate over the number of times you compound it, raised to the number of times you compound it times time. And so we will substitute our numbers in. Always look at the question. It says what amount. So you're looking for A. You're looking for A. And the principal was $2,000. You're multiplying times 1 plus the rate. Always change your rate to a decimal. And the number of times compounded quarterly means that K is 4. And you're raising it to the 4 times, and time was in 8 years. So if you can just use your calculator to put this in, and you can just enter it just the way I have it written down. So 2,000 times, or parentheses, 1 plus 0.06 divided by 4, parentheses, hat, parentheses, 4 times 8, parentheses. Or you could say hat 32. Everybody knows 4 times 8 is 32. And then enter. And this is money. So I think you can see that. So we would say the answer is $3,220.65. So the amount at the end of 8 years is $3,220.65. Always round to the hundredths place when you're dealing with money. So now you try to solve this problem, and I'll show you how to do it. You can hit pause. I will read it to you. If $5,000 is deposited into an account paying 1% interest, compounded weekly, what amount will be in the account after 7 years? Okay, you've had a few minutes to work on it, so let's see. If you put the principal is $5,000 and the rate is 0.011%, weekly means K is 52, and the number of years was 7. Now, I wanted to point out a common mistake that some students make. 52 times 7 you may not know off the top of your head. And it's very important that you enter the parentheses if you're using the calculator. So the correct answer is actually the first one that I got, $5,362.50. Now, some of you may have gotten $35,351.72. If you did that, that was incorrect. And the mistake you probably made was that you did 52 times 7 and didn't use parentheses. So when you do it that way, not using the parentheses, what the calculator understands is it's raised to the 52nd power and then taking that whole answer and multiplying times 7. And so that's incorrect. So you must use parentheses. Be sure you use parentheses with the exponents. So Euler was looking at this and he discovered E, like I talked about earlier. And so he came up with, instead of having this 1 plus the rate over K raised to the KT, if it's compounded continuously, this part really approaches the number E, and so he shortened the formula. And anytime you compound continuously, that's every millisecond, then you'll see this in the problems. It'll say compounded continuously, and anytime it uses that word continuous, you want to use this formula. And I always say, if you can remember Pert shampoo, you'll remember the formula, but it's the principal times the base E raised to, that's an exponent. It doesn't show the hat, but that's raised to the rate times time. So this problem is like number 3 on the take-home test. And so it says if $5,000 is deposited in an account paying 2% compounded continuously, then how much would you have after 5 years? And I'm kind of at the end of my page, so I'm going to use a regular pen to solve. But you would say, all right, the question is how much, so that's the amount, is equal to, the principal is $5,000, and I'm going to multiply that times E, and I'm going to raise it to the rate, which is 2%, so I'm going to use a parentheses, 0.02, and the time is 5 years, times time, which was 5 years. And so if you enter that in your calculator, I'm going to clear my calculator. So I have $5,000, and we have a button that does E hat. It's right here. If you go to the left of 4, it says LN, and up above it says E to the X. So you hit second, LN, and E hat, and it gives you the first parentheses. So we said 0.02 times 5. So 0.02 times 5, and close that parentheses and enter, and there's your answer. So I hope you can see that. $5,525.85. $5,525.85.